Welcome to yet another class. This is the part 2 of VT graph or velocity time graph. I have done part 1, so this is the part 2. Please do well to watch part 1. Now, for this part 2, we want to deal with questions like this. All of what we're going to be solving are past questions, the WAEC, NECO, and JAMB going forward. Now, let's start with this. We are told that this is the diagram. So we are told the diagram above represents the VT graph of a body in motion. The total distance traveled by the body is 195 meters. Calculate the acceleration of the body in the section OP. So I told you already for the first video that this is the acceleration. So first, we want to calculate this acceleration. That's what we want to calculate. Permit me to write it like this. So this diagram, this line up here is the acceleration of the graph. But also note that before you calculate acceleration, you need V. There is no speed given to us. So note that. Now, what do we do going forward? First thing is to get my V. That's the first thing, is to get my V. So before we get our V, what do we do? Now, first, bear in mind that we are given the total distance of everything here. So because we are given the total distance of everything stated here, we are going to still take this calculation one after the other for us to find V. So first, let's label it as 1. So the first diagram is 1, second diagram is 2, third diagram is 3. So let's label it like this. Now, what do we do for the first diagram? The first diagram, you can break it if you like. So this is it. Plus, the second is this one, rectangle, plus the next one is this one. So I have this going further. Now, from this part, what do I know now from this part? So we say total distance here is the combination of all this diagram. So we say is half base times V plus B times V plus half base times V. So this is the total distance. We already know that our total distance traveled is given to be this. So I'm going to introduce this here. So 195 will now give us this value times, I already know my B. My B from here to here, the first diagram now, will give us 6V. Let's put it like this. Here will give us 5V. Then here will give us 10V. So I have this. So I know that this value now will give us, here is 3. So that will give us 3V plus 5V plus, this cancels this, I have it as 5. Here will give us 5V going further. So if I do the math all together, here will give me 13V. So if I divide both sides by 13, I'm going to know my V. So what do we know as our V going further? So my V becomes 15 meter per second. So I've gotten my V here. So just add up the 3 diagrams and you will get your V. So I've gotten my V. So this is the first task here. Now, because I know my first task, we now have to calculate the acceleration of the body. Now, to calculate the acceleration of the body becomes easy. That becomes very easy. So how do I do that here? Becomes very easy here. So let's calculate the acceleration of the body. Let's calculate the acceleration of the body. So from this point, I'm going to now have that the acceleration of the body, therefore, which we know is A, to give us, we say change in V over change in T. Change in V over change in T. So we are calculating, this is what we are calculating, all of this. Look at this. This is what we are calculating. This one. That's this diagram. That's what we are calculating. So now, I know that my change in V will give us all of this value here, where we say from this point, for V, we are using this minus this. That means V2 minus V1. That's what we know. So this is my V1, this is my V2. So all over 40 By using T2 minus T1. So what do we now know there now? What is my T2? This is my T2, which we have gotten there to be 15. So 15 minus my V1 here, please, is 0. So I have 0 here. All over. Next, what is my T2? This is my T2, right? This is my T1 here. So I know that this one becomes, T2 becomes this minus this. So what do I know? I have 15 divided by 6. And I know that our A going further will give me 2.5 meter per second squared. So this is how you do this. I promise you, you are going to be so good at solving VT graphs. So good. So good. Please make sure, if you know you are writing JAMB, you are doing Post-UTME, you are writing this forthcoming GC and WAEC coming through, please make sure you are glued to this channel. If this is the first time of coming across this channel, kindly do it to hit the plus sign and also follow for more. Please subscribe to this channel as well. See you in the next question. All right, welcome to the number 2 or case 2 of the second part of VT graph here. So we have this diagram. Like I told you, we are solving past questions. So that's what we are solving all through, so that you will be so good when you are calculating this. So what do we do? This is the diagram here. So we are told that the diagram above represents the VT. VT means velocity time graph, the VT graph of a body in motion. Calculate the total distance of the body covered, of the body covered from the VT graph. So what do we know to do? It's simple as ABCD. Now, you have to be good at understanding how diagram works in mathematics. So if you check the diagram, this is a trapezium. This is a what? A rectangle. And this is a triangle. I already told you that whenever you have to calculate the total distance of a body, it's just to add up the 3 diagrams. That is all. Add it up. Because the body, when the body moves from this velocity here, it started, please, this is our velocity. Velocity measured in meter per second. What is our time? Measured in seconds. So it started moving from 10 meter per second and then move with this time, move like that up till this point. So what then do you think I just made? Sorry, please. For a trapezium, this part, so here becomes my 20, which is my A. Why this becomes my B? Because this is where the body starts from. This is my B. This is 20. A, this is my B. Why this becomes my height? Oh, so please, that is the movement. So here becomes half into bracket. So my A is, okay, my A starts from here, please. This is my 10, and this is my B, please. So that will give us 10 plus 20. The height is now 5, plus length is 20 times the breadth. So the breadth is this minus this. So please don't forget that. I have this, and plus I have base for this one is what is 5 here, then times my height. So my height is this is the height that all of them are making use of. So from here, I'm having here to be 30. 30 times 5 will give us 150 all over 2 here. Then here will give us 100 here, plus this can take care of this. Here is 10 times that, I will have 50 here. So from this part, if I divide this in 14, I'm going to have 7. In 10, I'm having 5 plus 100 plus 50 here. So I'm having that as 75 plus this 175 plus this. This will give us 225 meters. Yes, please. This becomes the total distance covered by the body beginning from here. This is how that is done. Going further, please make sure you share this video. Make sure you subscribe to my YouTube channel. Make sure you hit the plus sign, and also make sure you tell this channel or this page to your friends, your colleague for JAMB, for WAEC, for Post-UTME. Going further, this is the place for you to be. All right. So welcome to the number 3 question here. we have that the diagram below shows the VT of a car, velocity time of a car. We start from rest and it accelerates uniformly at the rate of this. Please bear in mind that whenever we talk about rate, we are talking about acceleration. That's the concept. And even if you are not told, check the unit. The unit is 3 meter per second square. Acceleration is measured in meter per second square. So observe that V is not given. V is not given for this seconds, meaning that we can get V from here. How do we get V? Please, this is A, the acceleration given to you. This part from here is 3 meter per second square. That's what is given to you. So how do we get here? We simply say recall. We simply say recall that we say V becomes U plus 8C. That's what we said for this. We are looking for this V. We know that from rest, they said from rest, that means my U is 0 first off. So here becomes 0 plus, what is my A giving to you? This is my A. My A is 3. For what time? 5 seconds. So here becomes this. So if you do that, 0 plus 15, do the math, you know that my V becomes 15 meter per second. So I've gotten here to be 15. That's my speed now. So how do we now calculate the total diagram now? The total diagram or the total distance. So we say for distance, which is total distance here, we say that total distance. I am calling this total distance because we are dealing with 1, 2, 3. We are adding up all the diagrams. For the first one, the first diagram here is what? It's called rectangle, which is this one times this one here. Then plus the next one is what? Rectangle. The next one here is what? Triangle or right angle triangle. So this is it. So from here times, what is my base here? My base is this one. This is my base. This is my base. 3. And then we are giving this one. So long as we have this, please note, please. So long as we have this diagram given here, that becomes yes, this becomes here. This part, this 3 here becomes my base. While the H here becomes my 5. Look at this, please. Look at this. From here to here, here to here is my 5. Then next up, the base becomes this one. Oh, what did I? Base, please, is 5. Please, this is 5, and then here is 3. It's 3. Please note that very well. This is 3 because this is given. This is what we are going to use, the base, and then this becomes the height here because that is given. If it was not given, we are going to be using this 15. So that was given. For only this first diagram, please note that, please. So next up, I'm having length times breadth. So length for this one is 15. What is my breadth here? This and this one will give us 60 here. Plus this value will give us the next value here. The next diagram here is this one coming down here. So we know our base. What's my base here? Is 3. It's 3. And then what becomes the height? The height is 15. Please, the reason why I use this one as 5 and 3 is because we are given this. The other diagram, we don't have anything like that given. So from here, I have here to be 15 over 2. Then plus, this will give us 900, please. And then this will give us, if you do the math, we are having 1545 given to us there. So I'm having 45 here. Remember, it's dividing by 2. So let's quickly not waste time. If you divide this one by 2, 15 divided by 2, I'll have it as 7.5. Let's not waste time. This is 900 plus, let's also not waste time. This will give us 22.5. 22.5. So add them up all together. Add them up. So we have 900 plus 22.5 plus 7.5. So I'm having all together to give me 9. Oh, sorry. This one is 37.5, please. 37.5. So it's giving me 960. This is how you calculate all of this. Please note this, please. Because the acceleration is given, I'm going to be using this and this, the base, and then this becomes the height, please, because this was given. Please note that very well. If it was not given, I would have used this one as my value. And also, watch the way I got this one, because we are giving acceleration and time, so we can get that very easily. Please do well to share this channel. Please, if this is your first time of coming, please do well to subscribe. Do well to hit the plus sign. Do well to follow. Share this. You need this. These are past questions we are solving from beginning to the ending. See in the next question. All right. Welcome to the fourth question here. So what do we know? They said this is a diagram given. This is a JAMB question, 1990. So what is the average velocity of the sprinter whose velocity time graph is shown above? What they are saying is that from here, the sprinter ran to this point, accelerated to this point, maintained the speed, and then decelerated here to this point. What does that mean? Everything. Calculate this, this, and this. That's all. That's what that means. So from here, we already know that since we want to calculate the average velocity, we know that velocity or velocity here, we know that is distance over time. That's all. You don't need to stress yourself. It's distance over time. That's all. So first, let's calculate. When we calculate all of this one, add them together, that becomes the distance. And then the time is this one, this 10. That's my time. And then we'll get our final answer. So let's do that quickly. So let's get our distance first. The distance now becomes, for this one, we have this value, base times height. Then we have length times breadth. Then base times height. So this is it. Now let's get our base for the first diagram. The base is this one here. So this one from here to here, 2 is this thing here. So I have here to be 1 over 2. The base is 2. We are using this one, the height here. Look at the height. That's the height. This is the height. The highest part where the sprinter maintained the speed is 10. So that's what they are all going to use. All the diagram uses that. So my length is 10. Breadth for this one, breadth is this and this. That's what we do. So this line, this one here, and this line, this one here. So 8 minus this one here will give us 6. So I'm having 6 here. Then times this value times the base for this one. This minus this one is 2. Then the height is that value there, which is 10 all together. So this can take care of this. I'm having here to be 10 plus this is 60. Then this cancels this. I'm having it to be 10 here. That's what I'm having. So from this point now, so what do we now do? When you add up all of this one, this is 70, 80. So here becomes 80 meter because this is our distance. So because we have gotten this now, we'll come back to this one. They said the average velocity. That's what we have to look for, velocity. So we say velocity here becomes what? 80, which is our distance, divided by the total time. The sprinter started from here and ended here. Where the sprinter ended is your total time. So my total time is 10. So when this cancels this, here becomes 10 meter, 8, sorry, 8 please. 8 meter per second. This is how you do this. Please do well to share this channel, follow this channel, subscribe to this channel, tell people about this channel, because here we'll learn a lot of past questions. We are solving the case 2 of VT graph. We are solving a lot of it. See you in the next question. So welcome to the 5th question in velocity time graph. So this is the question, and then we are told that the diagram above shows the VT graph of a car in motion. Find the total distance covered during the first acceleration and retardation period of the motion. We want to calculate them together. First, I'll have this one written here. So first, let's calculate the acceleration first. The acceleration of the car. For the acceleration of the car, it talks about, so this is my I. It talks about the movement from here. I told you that here is always my acceleration. Don't forget it. So this is my acceleration here. So which is this diagram? This diagram. That's what we want to calculate for. So you can say 1 over this times B times H here. So From this part, the base is 10 already. We know that. I have it as 10. And then the height, we know this is 10. That's the height. So that this takes care of this here is 5. And then everything here becomes 50 meters. That's what we know to do. Next up now, then B or I to calculate the retardation. So the retardation of the car, that is where the car came to rest from here. This becomes my retardation or deceleration, anyone you want to use, retardation or deceleration of the car. So it comes down to this point where we have that here, check diagram again, it's still a triangle. So we have it as 1 over this times B times H here. So 1 over this times, what is my base here? We are subtracting the big one from the small one, 50. Well, this one will give us 10 here. What's my height? My height is this one, 10 here. So do the math here. Do the math. I'm having it to be this to be given as, so the total retardation of the vehicle from here is given as this value here. That's 50 minus this, that will give us 10. So from here we will have that this point will give us 50 as well, 50 meters. So that's what I'm having. So how do we therefore calculate the total period of the car, the total distance, of the car? Because we're talking about acceleration and deceleration here. How do we do that in question? So we are going to be adding all of the values that are given to us. So we have that from this point. All right, please observe that this 50 is not among the motion from this point of origin or rest to this point, is outside. That means that from this 40 there is supposed to be another number here, that number, because we are having here to be 45. Please, this is 45, please. This is not in the question. First off, this is not in the question, but this is where the car retardated to, or the car came to rest. So for this point, we already know that this one is 45. And how do I know that? Is given to be this. This is it. So there is a motion or a movement of the time from 40 to 50. There is a value there here. So when you add 5 to this one, you get 50. So that is the movement. So please, this place for the car retardation, please, this place becomes, remember, if I subtract this, I'm going to have 5. This minus this, I'm dealing with this one. So here it's supposed to be 5, not 10. It's supposed to be 5, please, not 10. So that when I cancel this one, this becomes 25, please. So here becomes 25. So therefore, if I add them, because we have to calculate the total distance, if I add them, I'm having 25 plus 50 here. Everything becomes 75 meters. So this is how you calculate the total distance of this. From when you add acceleration and deceleration together, you get that put together. Please do well to subscribe. Please also follow this channel. This is where we solve past questions. WAEC JAMB, NECO, Post-UTME. You are lucky to see this channel. You are most lucky to see this channel. All right, this is the number 6 question here. This is what is given. The diagram shows the VT graph of a vehicle. Its acceleration and retardation respectively are, so this is JAMB question 1999. So please observe this thing. Where the something retardated here is 90. So here is on this line to be 90. And also note that, please, because we calculate the total distance, let's say we want to calculate acceleration now, we can use, for this diagram, we can use half base times height. Please, also in science, please, whenever you do a thing like this and this thing is not in the option, please, you can also use this. We want to also use this. V is equals to U plus AT. This will also give you acceleration because we want to calculate acceleration here. So do not only stereotype your mind into thinking that it's only this one, it's only this formula we are using, because I'm talking about diagram. Yes, please note that it changes. Science changes. Science is like nature. In fact, science is nature. The way nature changes, that's the way science changes. So please, so why am I saying so? It's because I'm not going to use half base times height here. I want to calculate acceleration here. So how do I do that? Now, the first thing I'm going to do in this case is, to calculate my acceleration, to find the acceleration of the vehicle, we are going to say V becomes U plus AT. This is what I'm going to use to get my acceleration. So we already know our V. What is my V? My V is this one, AT. The vehicle starts from rest. So here is the origin where this is always 0 here. So here becomes 0 plus my A is what we are looking for, but we have time. So my time becomes 20A. We're looking for A, don't forget that. So here becomes this, and I have here to be this one. Divide here by this, divide here by this. So that this takes care of this, and then my final value becomes 4 meters per second square. So this is it. B, or II, to find the retardation, or the acceleration. We know that acceleration, retardation or deceleration is the same as acceleration. Don't forget that. It's the opposite. This retardation and deceleration are together, but it's the opposite of acceleration. So how do we do that? Here, for this case, I'm going to use this variable where we say retardation, which is A, the same A you are going to use there. So we say it's change in T over change in V. Sorry, change in V over change in T. That's what we know. Yeah. So at this point, initially, U is this one, V is this one. But the moment the car comes to this place, before the something starts decelerating to rest, it changes. Here becomes my U. Why this place where the car drops as it comes to rest, V here becomes 0. Don't forget that. V becomes 0. So my U becomes this one. Do not forget that. So at this point, I can simply just say that to get my V, we say is this becomes, here becomes V2 minus V1 over T2 minus T1. Don't forget that. So here's my V1, while here becomes my V2. So 80, okay, this point here, as the car changes, please, this point here becomes my U. Don't forget that. So here becomes my V1. Here becomes my V1, while here becomes my V2 because it's retardating here. So here I will now have 0 minus 80 all over my T, the time for all of this to happen. Here, this one minus this one, that's the total time. So this minus this, that will give us 90 minus 50. So I will have that here becomes 80 divided by this. Do the math. I will have A to become minus 2 meters per second square. So this is how these things are solved. This is how they are solved. Please don't forget, please. This thing, what I did here is from here to here, initially here's my U, and then as ascend to this place, this becomes my V. So if you trace them, here will be my V, here will be my V, my U. But the moment the car gets to this place where it maintains the velocity and drops to 0 here, here becomes my U, while here becomes my V, V here becomes 0. Yes, so here V becomes 0, this one here. So this becomes my V2, while this one becomes my V1. That's the 0 minus 80. This one, 0 minus 80. That's what we have. Deceleration or retardation should give you a minus sign. Yes, just note that. Just note that. And even if they're not putting a minus sign in the option, just know that the final answer here becomes 2. Yes, you can leave that. You can remove the minus. It also becomes 2. This is how you do that. See you in the next class. All right, welcome to the number 7 of velocity time graph. You see, I promise you, you will be so good at this thing. If you are writing Post-UTME, JAMB, WAEC, NECO, this is the best channel to be in. If this is your first time of coming across the channel, please kindly do it to subscribe, hit the plus sign, follow for more. You are going to learn a lot. Tell this to everybody around you and your community. So let's solve this. We are told that the diagram above shows the speed time graph of a car. If the speed time graph of a car, it said if the car covered a total distance of 600 meters in 25 seconds, calculate the maximum speed. I already told you, observe here, we are not giving anything. We are not giving V here. So observe the way we found our V the first time. So we are going to combine everything here. We know that total distance will give you everything about the diagram. So I have this one, everything about the diagram, half base times height, then plus length times breadth, then plus half base times height. So this is what I'm having here. So everything here is 600. So I have this value. So what's my base here? My base for the first one is 5. Remember, we don't have V, so we're using that as V. So I will use my base to be, the height now is V. Please don't forget that. Length, that's the height. Length there is V plus the breadth. This and this will give us 15. That's it. Plus 1/2. This one is this minus this here will give me 5 times the height is V. They are all sharing, all of them are using the same height. So what do we know here now? So I have that here becomes 600. This will give us 5V/2. This is times, please, times. Multiply this, I'm having 15V plus, do that, I'm having 5V/2 here. So here, I'll find my LCM. My LCM of everything here is 2. 2 in 2 will give us 1 times this one, I'm having this. 1 in this is 2 times this one, I'm having this. Plus this in this is 1 times this one, I'm having this here. So from this point now, I can cross multiply. Take this one, all of this one here, all these ones here. So if I do that, I'm going to have this will give us 40. So I'm having 40V to give us this times this one. I'm having 1,200. Divided by 40, divided by 40. This takes care of this. What is now my V? My value here becomes 30 meters per second. So here becomes 30 meters per second. See you in the next class. So welcome to the number 8 question here. So first off, let's observe that we are given the V. V is this part, the vertical line, while this, the horizontal line, is also given. So watch that. This line decelerated to this one here, this number here. So what do? They will have to calculate the motion. They say, what is the total, what's the distance traveled? What's the distance traveled by the car? What's the distance traveled by the car? That means this, and this. That's all. So we say total distance here. Total distance will give us the total diagram, the area of the total diagram. That's what we know. So here is length times breadth. The middle one is length times breadth. And then the what? The next one here, the last one here, is this one. So that's all we know. It's simple. So we want to calculate total distance. So here becomes this. What's the base of this one? Is just this 5. 0 here, this 5, times, what's the height there? The height is given to be 15 plus length. This rectangle, we have that as 15 times the base, this minus this. That will give us 10. Then plus half of this one times the base of the next one. This is 7. So I have 7 times height. The height is 15 here. So from this point now, what would I do from this point? So I will know, I know that everything everything here gives me, here I'm having here to be 75 divided by 2. Here I'm having here to be 150. Here I'm having here to be 105 divided by 2. So if I divide 75 divided by 2, I'm having 37.5 plus 150, then plus here 105 divided by 2, I'm having 52.2. So let's get the total distance now. So D, adding up everything, plus 150 plus 37.5, everything will give us 240 meter. This is the easiest and best way to solve this. Please kindly do well to hit the subscribe button. Follow for more. Tell this to everybody around. This is the best channel to solve past questions. See you in the next class. Bye-bye.